We're Group 18. This is a short presentation of our model for a steel portal frame warehouse designed using Autodesk Revit 2024 and a structural analysis with space gas. Our structure spans 14 metres with a total building length of 28 metres and eaves height of 10 metres. The base is a 400mm thick reinforced concrete slab extending 200 metres past the walls and 5 metres at each roller door side, providing forklift and vehicle access. The portal frame uses 12 restrained columns paired with rafters. Each frame is spaced at 5,600mm, giving a uniform load distribution across the 28-metre length. All members use standard Revit families duplicated for cleats and base connections, ensuring accurate detailing for future structural analysis. The roof frame uses Lysat purlins spaced at 1,420mm internally and 1,800 at the ends, well within the Clip Lock Classic 700 limits. Matching girts provide wall support with bridging angles added for torsion restraint, improving stiffness and preventing section rotation. The roof uses Clip Lock Classic 700 sheeting at a 6-degree pitch, which is above the manufacturer's minimum for efficient drainage. Walls use spandex cladding, giving durable and fast insulation. We included 10 fixed windows for daylight and 2 roller doors for cross-ventilation and equipment access, one at ground level and the other at mezzanine height for forklift loading. The mezzanine floor sits 4 metres above the ground with an 8 by 5 metre platform, accessed by stairs surrounded by safety railings. The elevated roller door enables forklifts to load materials directly onto the mezzanine, improving internal logistics and vertical storage efficiency. To add value beyond the brief, we introduced several innovative components. Roof gutters and downpipes manage stormwater effectively, protecting the cladding. A mezzanine level roller door provides a forklift access for upper floor loading. The slab apron was extended to create durable working zone, and an external car park adds safety and convenience for staff and visitors. These inclusions improve drainage, accessibility, and overall functionality. Additionally, we use space gas to assess how the portal frame would perform under specific design wind loads, as well as test the deflections, shear forces, and bending moments for both pinned and fixed conditions. The structure was designed for Wollongong Sydney region, which under AS 1170.2 falls within region A2. This means we consider design wind speed of up to 155 km per hour. These wind loads were applied to the test frame's response under realistic site conditions. When comparing pinned and fixed supports, the analysis showed negligible differences in overall deflection. This indicates that the portal frame is structurally rigid and well braced, maintaining stability under lateral wind forces. For shear forces, results were again quite similar between pinned and fixed bases. This demonstrates that the shear demand on the members is consistent and within acceptable design limits for both boundary conditions. In terms of bending moments, the key difference occurs in the columns. With pinned supports, the columns experience minimal movement, while the fixed supports, moments develop at the base, improving rigidity but increasing design demand on the base plate. The base plate uses a 450 by 22 by 20mm plate with 4 M20 bolts. All tension, shear and weld checks pass successfully with a utilization ratio of 1.79, indicating full but safe use of the section's capacity. At the rafter-to-rafter apex connection, a 550 by 200 by 25mm plate with 8 M20 bolts was used. Both weld and bolt checks passed with a utilization ratio of 0.99, almost perfectly optimized. The knee connection, where the column meets the rafter, used a 550 by 180 by 25mm plate with 8 M20 bolts. Stiffeners of 76 by 6mm were added to control local buckling, and all checks passed with a utilization ratio of 0.9. In summary, the space gas analysis confirmed that the portal frame is structurally efficient and compliant with the relevant design standards. Both pinned and fixed cases performed well under wind loads, and all key connections met strength and serviceability requirements. We have been Group 18. Thank you very much for joining us.